So we have line L and line K. We say that line L is perpendicular to line K if they intersect to form 4 right angles. So all 4 of these angles would be right. Recall that a right angle has an angle measurement of 90 degrees. So each of these right angles would all have the same angle measurement, and therefore they are all congruent. On a diagram, if you see a square, this is the symbol on the diagram for perpendicular. And when we write it out, this is a symbol for perpendicular. So for problem 1, we're going to go ahead and draw 2 parallel lines. We will say that line M is parallel to line N. And to show that symbol for parallel on a diagram, we would put these little arrows or feathers. We will now draw a perpendicular transversal. So instead of drawing a line that goes diagonally, we're going to draw one that goes straight up and down. If it's perpendicular, that means that it forms a right angle. So how do I show the symbol for perpendicular on a diagram? It's by use of these little red squares, little squares that indicate that these are perpendicular. I will call my perpendicular transversal K. So we could say that K is perpendicular to M, and K is also perpendicular to N. I can only make those claims because I have these symbols on my diagram. So if these are perpendicular, well, let's go ahead and label each of these angles. I've labeled them 1 through 8. Now, we know that angle 1 is 90 degrees. But we also said that when we have 2 lines that are perpendicular, they form 4 right angles. So because line K is perpendicular to line M, these 4 angles are all right angles, and all right angles are congruent. If we look at the second case, where K is perpendicular to line N, we know that 2 lines are perpendicular form 4 right angles. So we know that angle 5 is 90 degrees, and so is angle 6, and angle 7, and angle 8. So the big takeaway here is that for all 8 angles, since they are all right angles and they're all congruent to each other, angles 1 through 8 are all 90 degrees. Let's do a proof. Now, as we continually do proofs throughout this entire school year in geometry, please be aware that we will always be using former properties, theorems, and definitions, along with new ones that we learn in every proof that we do. Let's first study out what's been given. We know and have been given that H is parallel to K. You'll note that it's been labeled for us already. It has the feathers. So we can assume confidently and know that H is parallel to K. We've also been given that J is perpendicular to H, and we see that square right there indicating that. You will note that it was not labeled like that down here, so you don't see a square here, or here, or here, or here, because that was not given. That is what we're going to prove. And this is never something that we just use in a proof. The proof statement is the end of our proof. In other words, what we're going to find. Well, of course, we start with our given statements. And our given statements are pretty important because knowing that these 2 lines are parallel is going to allow us to use angle relationships like corresponding angles or consecutive interior, etc. Knowing that J is parallel to H will allow us to know what the angle measurements are equal to. So for example, if we wanted to pick angle 2, we could say that angle 2 is 90 degrees. The question is, how do we know that? Well, we were given that J is perpendicular to H, and we know that if 2 lines are perpendicular, then they form right angles. So if angle 2 is 90 degrees, and if H is parallel to K, then how are angle 2 and angle 6 related? If these are parallel lines, How are angle 2 and angle 6 related? Well, we know they're corresponding angles. And we know that corresponding angles are equal to each other. They're congruent to each other. Now, we see that angle 2 is 90 degrees, but angle 2 is also equal to angle 6. So we can go ahead and substitute, right? It doesn't follow the right pattern for transitive property in this case, but by substitution, we can say that angle 6 is equal to 90 degrees. That means if angle 6 is 90 degrees, what kind of lines form 90-degree angles? Well, we know that perpendicular lines, when they intersect, they form 90-degree angles. They form right angles. So by definition of perpendicular lines, if angle 6 is a 90-degree angle, if it's a right angle, then that means J and K are perpendicular, and we're done with this proof. As always, I invite you to think about this proof, go back and try it out for yourself, prove it to yourself. Don't just blindly write what I write. Think about it, study it, learn it for yourself, own it. For the summary, you know, I warn you about this in every video. We keep adding more and more and more each time that we talk. Now we're adding perpendicular, right? We've used words before like adjacent and linear pairs and congruent and complementary. But let me just kind of recap a few of these things. Adjacent angles are angles that are touching each other and that share a common ray and vertex. So for example, in this case, angles 1 and 2 are adjacent. A linear pair is a pair of angles that forms a line. We say that angle 1 and 2 are adjacent angles and they form a line, and therefore they form a linear pair. So we would say angle 1 and angle 2 form a linear pair. What if we had this linear pair? So what if we said angle 1 is equal to angle 2, and we're also saying that angle 1 and angle 2 are a linear pair? You would recall by the linear pair postulate that angle 1 plus angle 2 would be equal to 180 degrees. Now, if angle 1 and angle 2 were the same, what must be true? Feel free to write down words or even do a proof if you'd like.